Yes, welcome to this economics. Today we're going to look on how we can solve the exponential function rule. This is also among the rules in differentiation. So derivative of exponential functions. Derivative of exponential function is the exponential itself if the base of the function of is e, the natural base of an exponent. Now for that case, let's look at an example. For example, example number 1, if y is equal to e raised to the power of x, then when you find the derivative on this function, it will be dy over dx, which will give you e raised to the power of x. So it remains the same, does not change in any manner. It remains the same, does not change. Suppose if also another example number 2, we are given that y is equal to e raised to the power of negative x. Derivative of this function will be dy over dx is equal to, we put out that negative e, but it will remain the same. You raise the same number, raised to the power of e, we raise the same e raised to the power of x as you observe. So this negative will come here, then you raise the same number of e raised to the power of x. So e raised to the power of negative x remain the same, whereby negative is being times on the left hand side of this base here. Now, third example number 3. Now, if y is equal to e raised to the power of 2x, then we find the derivative of dy over dx will be equals to, let's take 2 here, 2e times by base, then e raised to the power of 2x is remained the same. This will be the answer. Example number 4. You're given if y is equal to e x raised to the power square plus 3. From this kind of function, how we can derive the dy over dx, y over dx? First of all, let u be the equation of x raised to the power of 2 plus 3. Then you then after letting that, let u be this function over here. So after letting out this function, this means that our y will be equals to e, that is raised power of this value. It will be now e raised power of u. Now for that case, let u derivatize these functions over here. So when you derivatize out our dy over du, our formula that we apply is that dy over dx is equal to dy over dx times du over dx. Now for that case, when you apply the derivative change of dy over e, this will mean that our u will be raised power of u. Then this our u here is raised power of x cubic. So this means that when you apply the derivative function from this function will be equals to, it's like to say now our dy over dx is equal to respective value of du over du is given by taking out our u, e raised power of u. That will mean that our dy over dx is obtained after taking out y, which is equal to e raised power of x2 cubic. So when we raise power from this function here, the main out is du over dx, which is equal to, this will give you, when we derivatize of this function here, it will be dy over de or dy over du, or we sometimes simplify dy over dx, will give you the answer that is equal to e raised power of u. This means that it will never change, as you observe. Then you apply the derivative change of this function here, will give you from the e raised power of x squared plus 3. So this will give us the value that is equal to dy. It will be now dy over dx is equal to dy over dx, that is e raised power of u times du over dx. Du over dx, this means that from the function of u, which is equal to x raised to power 3, when you derivatize du over dx, the answer would be equals to, the answer would give out the value that is equal to x raised to power 2, that will give you 2x plus 3 from that figure. So when we derivatize, we take out the function, it will be u times a y that is equal to ex raised to power of 3. Since our u is equal to x raised to power of 2 times 3. So y, which is equal to e raised to power of u, dy over over dx is equal to raised to power of x squared plus 3, as you observe. So this is like to say, when we derivatize, we apply the derivative function, this function dy over dx, du over dx will give you 2x. So here with times 2x, that will be equals to dy over dx is equal to eu times 2x. This will be the answer. Let's look at another example for more understanding. For example, y is equal to e x squared. Now from this formula here, dy over dx is equal to dy over dx times u over dx. So from this kind of equation, we could let out our u, that could be y is equal to, let out u, which is equal to x raised to power square. After let me then find du over dx, which will give you 2x. Now after letting that, let you find the du as du itself. This will give you, we'll take out our u, which is equal to x squared, that will be equals to y, which is equal to u, which is equal to x raised to power of u. This will be given out our e raised to power of u, as observed. Now from that function, our du over dx is equal to 2x, but our dy over dx give out our e raised to power of u, dy over dx, that will give you dy over raised to power of u. So this, the answer will be now dy over dx is equal to du over dx, that is equal to e dy over dx, that is equal to a e raised to power of u, then times the derivative of du over dx, which is equal to 2x. So this would be the answer. E, that will be equals to raised to power of u. Since our u is equal to x squared, it will be e raised to power of x squared times 2x. This will mark our answer. Let's try to look at another example. Example number 3. So find du over dx if y is equal to e raised to power of x cubic plus 6x squared plus 10. So when you let out u is equal to 4x cubic plus 6x squared plus 10, which is the raised power function upward there. Now after taking that, let you find du over dx. This will give you 12x squared plus 2 times 6 is equal to 12 x, then plus constant, which is equal to 0. The equation remains as this. Now from this u function, it will demonstrate that our y, which is equal to e, raised power of this function is equal to u, so it's raised power of u. So the function here of dy over du over dx is equal to e raised power of u, as its constant does not change. Now after taking this, let you plug to our formula. Dy over dx is equal to dy over du is equal to du over dx times, take out dy over dx. So this is like to say it will be du over dx, which is equal to e raised power of u is equal to x squared, x cubic. It's like to say we take out this figure and times together du over dx. That will give you that is equal to, we take out our dy over dx, which is equal to a u times dy over dx, that is 12x squared plus 12x. So remarkably, this will be dy over dx is equal to, since our u is well known, so we could plug in our u here, which is actually e raised power of u. Our u is equal to 4x cubic times 6x squared plus 10. Then we could times with our 2x 12x squared plus 12x. So this becomes the answer. So thank you and welcome to DC Economics. Don't forget to subscribe. Bye bye.